So in this video, we are going to look at the CSEC Math June 2018 Paper 3. So here we have our first question, where the internal angles in degrees of a quadrilateral, and you know a quadrilateral has 4 sides and also 4 interior angles. So those interior angles are 12x plus 15, 17x take away 10, x plus 50, and 15x plus 35. So here they want you to find the value of x. Now you should know that the sum of the 4 interior angles of a quadrilateral is equal to 360 degrees. So we're going to put the 12x plus 15, we're going to add the 17x, take away 10, and we're going to add the x plus 50, and we're going to add the 15x plus 35, so that's all 4 of them, and they must be equal to 360 degrees. Now I did a little shading to show you the 4 angles, which would be 12x plus 15, look at here. The 17x take away 10, look at here. The x plus 50, look at here. And the 15x plus 35, look at here. So 1, 2, 3, 4. The sum of the 4 interior angles is equal to 360 degrees. Now I just wrote over the stop line down here because now I want to bring the like terms together. So I'm going to bring all the x's together. And just remember, the signs in front of the number is part of the number. So I'm going to have positive 12x, positive 17x, positive x, positive 15x. So let's write those out. So positive 12x, positive 17x, positive x, and positive 15x. Then I'm going to bring my constants together. So that's positive 15, negative 10, positive 50, and positive 35. So writing that out, we're going to have positive 15, negative 10, positive 50, and positive 35. And that will be equal to 360. So adding the 12x plus 17x plus 1x plus 15x, I would get 45. So that would be 45x. And now positive 15 take away 10 plus 50 plus 35 is equal to positive 90. So I'll have positive 90 is equal to 360. So now I'll transfer this positive 90 across the equal sign. I'll turn to negative 90. So we'll have 45x is equal to 360, take away 90. So we'll have 45x is equal to 270. So now x would be equal to 270 divided by 45. So x is equal to 6. So here we have part B, where they say the diagram below, not drawn to scale, shows 4 straight lines. So POQ, so that's POQ here. OA, that's here. OC, that's right here to here. And CB, that's right here. Right, these are our 4 straight lines. And then we have OA is parallel to CB. So OA is parallel to CB. Now you can see that on the diagram with these arrows, right? These arrows suggest that we have parallel lines. Now down here, they're telling us that given that OA bisects angle POC, so that's this line here, OA bisecting the angle P to O to C, all right, and angle OAC is 62 degrees. So if here's 62, this is P to O to C, and then this line OA bisects this angle, then if here's 62, then here's also 62. All right, so we have that. Now, they want us to find the value of angle A. All right, so angle A is here. Now, when we have parallel lines, we look for alternate or corresponding angles. So, the alternate angles, we look for the shape, the Z shape, and the corresponding angles, you look for the F shape. So, I'm seeing an F here. All right, so let's see what we have. So, if here is 62 degrees, then this angle right here would also be 62 degrees. Because those will be corresponding angles. And now if here is 62 degrees, this is a straight angle, so A plus 62 would make up a straight angle. So A plus 62 must be equal to 180 degrees. So we'll have A plus 62 degrees would be equal to 180 degrees. So A is simply equal to 180 degrees, take away 62 degrees. So A will be equal to 118 degrees. Now for part 2 of this question, they want you to calculate the value of the angle B. Now we could see a straight line here. So the 62 plus this B would form a straight angle. So these three angles must add up to 180 degrees. So for part 2, I'm going to have 62 plus 62 plus angle B would be equal to 180 degrees. So 62 plus 62 is 124. And now we carry across that 124. And we have 180 degrees, take away 124. All right, so angle B is equal to 56 degrees. So here we have part C, and we have for this question, you may find the following formulas related to a cone useful. So here we have the volume of a cone, which is 1/3 the area of the base, and the base is a circle, times the perpendicular height. So this is your cone here. The base is the circle. The perpendicular height we have here is 1.2 meters. And the curved surface area is equal to pi r times the slant height. So the slant height is L here, this L, this is the slant height. So we have a farmer constructs a storage tank as shown in the diagram below. The shape of the tank consists of a cylindrical body, so that's the cylindrical body here, of height 3.5 meters, so that's the height here, 3.5, diameter 8, so the diameter is 8, the radius is 4, half the diameter, and the conical roof vertical height is 1.2 meters. So this is the conical roof, so this is your cone, and the height is 1.2 meters. That's the perpendicular height. So they want us to use pi as 3.14, and the first question is to calculate the slanted height, L, of the roof of the tank. So that's L here. Now the first thing we must observe here is that for a cylinder, this circle down here at the base is the same circle on top here. So if the diameter of this circle is 8, the diameter on top here is also 8. As I said, the radius will be half the diameter, which will be 4. So this line here would be the radius of the cone, which is also the radius of the circle for the cylinder, and that will be 4 meters. So I'll put in that. This is 4 meters. So what we have here is a right angle triangle. So you can use Pythagoras theorem to find the length of the hypotenuse here, which is the slanted height. So what I drew here is the right angle triangle, showing you the 1.2 meters. That's this here, 1.2 meters. And that we have the 4 meters down here, which is this 4 meters here. So my slanted height L would be here. Now we know if you draw a line from the right angle, it will touch the hypotenuse. The hypotenuse is side opposite the right angle, or the longest side on the right angle triangle. So this here would be my hypotenuse. And Pythagoras theorem states that the square on the hypotenuse, so that'll be L squared, is equal to the sum of the squares on the other two sides. So that will be 1.2 squared plus 4 squared. So I'll have L would be equal to the square root of 1.2 squared plus 4 squared. So L would be equal to, so I'll just pull my calculator up and I'll type in the square root of, open brackets, 1.2 squared plus 4 squared. And close the brackets. And that will be equal to 4.176. So I'll write that as 4.1. So I'll write that as 4.18. So 4.18 meters. Now for part 2 of this question, we're going to assume that the storage tank is completely sealed and is filled with diesel from an opening at the top. Find the capacity in meters cubed of the tank inclusive of the conical roof. So basically what we want to do is find the volume of the cone and also the volume of the cylinder and add it together. So just remember the base of the cone is this circle. So what we can do is find the area of the circle first. So the area of the circle is equal to pi times r squared. And we know the radius is this 4 meters here, right? That's the radius of the circle. So we're going to have pi, and they say use pi as 3.14. So 3.14 times radius squared, which is 4 squared. So that'll be equal to, so we have 3.14 times 4 squared. All right, and that's equal to 50.24. So we have 50.24 meters squared. So now the volume of the cone is equal to 1/3 times the area of the base, and the area of the base is the circle, so that's the area of the circle, times the perpendicular height. And we know that perpendicular height is that 1.2 meters. So we're going to have 1/3 times the area of the circle, which is the 50.24, times the perpendicular height, which is 1.2. So that's equal to, so on our calculator, we're going to have 1/3. We're going to multiply that by the 50.24, and we're going to multiply that by the 1.2. And we're going to get 20.096. I'll just write that as 20.1. Right? And that will be meters cubed. And now for the volume of the cylinder, as we know the cone is a pyramid, that's why we had 1/3 the area of the base times the perpendicular height. Now the cylinder is a prism, so we're going to have the area of the cross section, which is the circle, times the perpendicular height, which is 3.5. So I'm going to put the area of the circle. And remember, the area of the circle is the cross section times the perpendicular height. All right, so again, the area of the circle is 50.24 times the perpendicular height, and that's of the cylinder, which is 3.5. And that will give you 175.84 meters cubed. Now, the capacity of the tank would be equal to the volume of the cone, which is the 20.1 meters cubed, plus the volume of the cylinder, which is 175.84 meters cubed, which will be 195.94 meters cubed. Now for part 3 of this question, we're going to show that the total curved surface area of the tank to the nearest square meter is 140 meters squared. Now I want to recall the formula that they give us for the curved surface area of the cone. All right, is pi r times the slant height. All right, so just remember that from here for this question, you may find the following formulas related to a cone useful. All right, so this is the curved surface area of the cone is pi r times the slant height. Now also recall that the slant height L we found to be 4.18 meters. So that's the slant height of the cone. All right, so I just put back into the diagram the 4.18 meters. This is the slant height. And of course, I put back in that the radius of the circle is 4 meters. That's the radius r. All right, so first we're going to calculate the curved surface area of the cone. Will be pi times r times the slant height L. All right, so pi we're using as 3.14. The radius is 4 meters. And the slant height is 4.18 meters. So that'll be equal to 52.5 meters squared. Now we have to work out the curved surface area of the cylinder. Now we know the net of a cylinder consists of a rectangle and two circles, and the rectangle forms the curved surface area. So now we have to find the curved surface area of the cylinder. So now the net of a cylinder consists of two circles and a rectangle. So here we have the net of the cylinder where these are the two circles and this is the rectangle. So this here will be the radius, and the radius for that circle will be 4. All right, so let's put in the 4 meters here and here. And now this rectangle will be curved surface area. Now what we know about the rectangle is that this will be the perpendicular height of the cylinder. So that will be the 3.5 meters here. So 3.5 meters. And we know that the this length of the rectangle is equal to the circumference of the circle. So that will be 2 pi r. So the length of the rectangle is 2 pi r, which is the circumference of the circle. So the area of the rectangle will be equal to length times breadth, or length times width. And the length is the circumference of the circle, which is 2 pi r, times the width. And the width here is 3.5. So now putting in pi as 3.14 and radius as 4, we'll have the area of the rectangle be 2 times pi, which is 3.14, times the radius, which is 4, times the 3.5. So that'll be equal to, and that'll be 87.92 meters squared. So the curved surface area of the cylinder is equal to the 87.92 meters squared. All right, that's because the curved surface area of the cylinder is equal to the area of the rectangle. That's here. So now my total curved surface area would be equal to the curved surface area of the cone, which is 52.5, and adding the curved surface area of the cylinder, which is 87.92. And that will be equal to 140.42 meters squared. And that'll be approximately 140 meters squared to the nearest meter. So approximately 140 meters squared. So for part 4, the farmer wishes to paint the exterior of the tank. Now, given that 1 gallon, so we're saying that 1 gallon is 3.79 liters. So that given that the 1 gallon of paint covers 30 meters squared of surface, which is the surface area, determine the amount of paint needed in liters to completely paint the exterior of the tank. Now, we're going to assume that the farmer is not going to lift up the tank to paint the base of the tank. All right, so it's just the curved surface area he's going to paint. So we know that the total curved surface area we found to be 140 meters squared. So now if 1 gallon, which is equal to 3.79 liters, all right, covers only 30 meters squared of surface area, what we'll need to do is divide this 140 meters squared with the 30 meters squared. So we'll get the amount of gallons of paint required. And then we can multiply it by the 3.79 to get it in liters. All right, so here I have the amount of paint required in gallons would be the 140 meters squared, which is the total curved surface area, divided by 30 meters squared, which is what 1 gallon will give you. So that'll be approximately 4.67 gallons. So now the amount of paint in liters will be multiplied at 4.67 gallons times the 3.79 to convert the gallons to liters. So times 3.79. And that will give you 17.7 liters. So now we have question 2, part A, where we have a toy rocket is projected upwards from a point O. So its starting point is O, and that's on level ground. Right, so level ground is also assumed to be horizontal ground. And the vertical height it travels can be modeled by the quadratic function. So we have h of x is equal to 4 to x, take away 8x squared. Now notice that the negative 8 is in front of the x squared, which suggests that this is a maximum curve. So we're saying that x is the horizontal distance traveled from the point O. All right, so if x is the horizontal distance traveled from the point O, then that suggests that O is the origin. All right, the start point, the origin. And x being the horizontal distance will be x-axis, and h of x would have to be a vertical distance, which would be the y-axis. So what I did is I drew a diagram to sort of give you a visual representation of what is taking place. So the rocket is starting off at O, right? It's going up and then it's coming back down. This parabola is a maximum curve modeled by this quadratic function, h of x. So the first question, they want to find the vertical height. So vertical height, when the rocket is at 1 meter away from O. So that'll be horizontal distance 1 meter away. So basically, visually, what we are saying is that when x is 1, all right, 1 meter away from O, we want to know what is the height. So that'll be substituting x is equal to 1 into a function h of x to get this vertical height here. All right, so we know h of x is equal to the 40x take away 8x squared. So now substituting 1 in for x, we'll have h of 1 is equal to 40 times 1 take away 8x squared, so that'll be 1 squared, right? 8 times 1 squared. So 1 squared is 1, so 40 times 1 is 40. Take away 8 times 1 squared, and 1 squared is 1. So that'll just be 40 take away 8 by 1 is 8. So that's just equal to 32 meters. Alright, so that's h of 1 is 32 meters. So that just means the height here is 32 meters when here is 1 meter. Alright, so my vertical height when the rocket is 1 meter away from O would be 32 meters. Now for part 2 of the question, you want to determine the distance from O when the rocket returns to the ground. So I'm just going to bring back my diagram to represent what is going on. So the rocket is leaving at the origin O, that's when the height is equal to 0, it's going up, and then it's coming back down to 0, that means the height is 0 again. Now remember, the height is the vertical axis, which is represented by h of x. So the rocket is on the ground at 2 points. That's the beginning here and where it ends here. And at these 2 points, the vertical height h of x is equal to 0. So what I'll have to do is replace this h of x with 0 and solve the equation for x. And I'll get the horizontal distance where the rocket starts and ends. Alright, so I write h of x is equal to 40x take away 8x squared. Now putting h of x equal to 0, that'll be equal to 40x take away 8x squared. If you don't feel comfortable working like this, there's no problem to write it the other way around, which is 40x take away 8x squared is equal to 0. What I will do here is I could factorize. So I'm seeing that 8 could go into 45 times, and also x could go into x squared. All right, so our HCF would be 8x, so open brackets. All right, divide the 40x with 8x, and we will get 5. All right, we divide 8x squared with 8x, 8 cancel 8, and x into x squared x. So we get take away x, which is equal to 0. So now we'll have either 8x is equal to 0 or 5 take away x is equal to 0. So obviously here we'll have x is equal to 0 divided by 8, which means x is equal to 0. And here we'll have, we can just carry across the negative x and have 5 is equal to positive x. So that's mean x is equal to positive 5. All right, remember these distances are in meters. All right, so we have our 2 answers, and I said the 2 answers will be where the rocket starts, right? Which we know its starting point is x is equal to 0, so that's this one here. And the next one will be where it ends. So the end point would be 5 meters. So it's 5 meters away from the origin. So this point here is 5 meters away from the origin. So I'm just going to put start here. And end here, meaning it starts at 0 meters and ends at 5 meters in terms of horizontal distance. All right, so here I'm making my statement that the rocket returns to the ground 5 meters away from O. So remember when we did this working, we got 2 answers. So I'm just specifying that this is my answer, the 5 meters. So for part 3, you want to know what is the value of x when h is the greatest, and h is your vertical height. So we want to calculate the value of the greatest height. So I'm just bringing back my diagram to represent what is going on. And what we have here is a maximum curve, right? H is the height, h of x, the height. All right, and what we want to know is the turning point, the value, the y value for your turning point, and also the x value for your turning point. All right, so let's put a drawing here to show you. All right, turning point will be here. So we want to know is the x component and what's the y component. So I just want to recall our quadratic expression. H of x is equal to 40x take away 8x squared. And I'm going to write it this way. H of x is equal to, I could put the negative 8x squared first, and then the positive 40x. All right, and this would mean that a is equal to the negative 8, and b is equal to 40. Of course, the constant c, the y-intercept, would be 0. So I'll put 40 turning point. All right, we'll have the x component is equal to negative b over 2a. So that'll be negative, and b is 40 over 2 times a, and a is negative 8. All right, so we have negative 40 divided by 2 by negative 8, which is negative 16. So we have x is equal to, all right, positive 2.5, which is 2.5. So just remember, you're dividing two negatives, so you're going to get positive. All right, so we get 2.5. So now I can put in that x component here as 2.5 meters. All right, that's now putting meters here as well. So now that we know the x value for the greatest height, we just have to substitute this x value into a quadratic expression to get the y value, which will be h of x. So I'll put when x is equal to 2.5 meters, h of x is equal to negative 8x squared plus 40x. So that's negative 8, and x is 2.5. Right, you're going to square that, plus 40 times x, which is 2.5. Right, and that's equal to, this will be h of 2.5, right? All right, so h of 2.5 is equal to, and I'll pull my calculator up for this. So I'll press negative 8, all right, open brackets. We're going to have 2.5, close brackets. We're going to square it like that. Then put plus 40, open brackets, and 2.5, close brackets. And that will be equal to 50. All right, so h of 2.5 is equal to 50, and put the 50 meters. All right, so that means my greatest height here is 50 meters. So my turning point, put as TP, is 2.5 and 50. So I'm writing my solution here that the greatest height is equal to 50 meters when x is equal to 2.5 meters. Now, instead of doing this working, we could have also complete the square on this h of x to obtain the turning point. All right, so I just want to demonstrate that here, where we're going to complete the square. So I'll write this as h of x. I'll just write the x squared first. So that's equal to negative 8x squared plus 40x. All right, what I want to do is factor out the negative 8. So we'll have this is equal to negative 8, right, open brackets, divide negative 8 squared by negative 8 and get positive x squared. And we're going to divide positive 40x with negative 8 and get negative 5x. All right, I'm going to close brackets here now. All right, so now I'm going to set up my brackets for the perfect square. All right, so it's my brackets for the perfect square. I'm going to write back the x. Okay, I'm going to bring down this negative sign. All right, and I'm going to find half of 5. All right, so half of 5 is a half multiplied by 5 over 1, which is simply 5 over 2. So a half of 5 is 5 over 2. And we're always going to take away that number squared. So taking away 5 over 2 squared. All right, and now I close back my brackets like that. So we have the negative 8, open brackets again, x take away 5 over 2 squared, and of course, we square that 5 over 2, so square 5, you get 25, and square 2, you get 4. So now what we got to do is get rid of this big brackets here by multiplying everything inside of here by this negative 8. All right, so we have negative 8 times this. And seeing that we have this square sign here, we can't expand this. So we just write back negative 8, open brackets, x take away 5 over 2, close brackets squared. And now we multiply negative 8 by this negative 25 over 4. That will be negative 8 over 1 multiplied by, well, negative 25 over 4. I'll put negative here, negative 25 over 4. All right, now obviously multiplying two negatives, you're going to get positive. So we can ignore these signs and there's no answer going to be positive. And what we're going to have here is 4 into 4, 1, 4 into 8, 2, because that's negative 2. All right, so we're going to have the 2 by 25, and of course, two negatives are positive, so you're going to get positive 50. All right, so positive 50. Now we know 5 divided by 2 is 2.5. All right, so what we have is negative 8. X is equal to 5 divided by 2 is 2.5. And the positive 50. So we know that the 50 is our y component of our turning point. All right, so positive 50, and we know we change the sign inside here. So if this is negative 2.5, the x component will be positive 2.5. All right, so our turning point would be positive 2.5 and 50. So this will be a greatest height, 50 meters, and this will be the value of x for that greatest height, 2.5 meters. Now moving on to part B, we have some coordinate geometry here now. So P is the point with coordinates negative 2 and 3, so that's P. And Q is the point with coordinates negative 5 and negative 1. So let's write that down, that P is negative 2 and 3, and Q is negative 5 and negative 1. Now we want to show that the gradient, which is M, of the straight line that passes through the points P and Q is equal to 4 over 3. So we know our formula for gradient is equal to our change in y over change in x, which is our y2 take away our y1 divided by our x2 take away our x1. And our coordinates are right here. So we know that this is x1 and y1, and then this here is x2 and y2. All right, so our y2 is this negative 1 here. So negative 1 take away our y1, which is positive 3, divided by our x2, which is negative 5, take away our x1, which is negative 2. So that's negative 2 like this. All right, so for the numerator, right up here, we have negative 1 and negative 3. So two signs are the same, so you're going to add and keep the negative sign. All right, so we're going to have negative 4, right? 1 plus 3 is 4, keep the negative sign. And for our denominator, we have these two negative signs together, so we're going to multiply them, and negatives are positive. All right, so we're going to have negative 5 plus 2. All right, so now our two signs are different, so we're going to subtract 2 from 5 and get 3, but 5 is the bigger magnitude and the sign is negative, so that's negative 3. All right, so we have negative 4 over negative 3. And of course, if you're going to divide two negative numbers, you'll get a positive answer. So the answer is positive 4 over 3. All right, so we have M is equal to positive 4 over 3. So now for part 2, we have that the equation of a straight line that is perpendicular to PQ. So let's stop right here. So the line is perpendicular to PQ. We learned across here that the gradient of PQ is 4/3. Therefore, the gradient of a line that's perpendicular to PQ would just be the negative reciprocal of 4/3, which would be negative 3 over 4. And we say that this line passes through the point 5, 2. All right, so we're going to write the equation in this form, and we're going to know the values are A, B, and C. Now, we know if we're going to find the equation of a line, we need two things, the gradient and any point the line passing through. So we have the point that the line is passing through. All right, so we have a line passes through. All right, 5, 2, so we have that. And then we need the gradient of the line. All right, so I have the gradient of line perpendicular to PQ. So let's recall that the gradient of PQ is 4/3. All right, so that the gradient of the line perpendicular to PQ is the negative reciprocal. So that means we flip this fraction. So we get 3 over 4 and change the sign. All right, so that's negative 3 over 4. All right, so flip and change sign. All right, so we're going to have negative 3 over 4. I'll just recall that the gradient of PQ was equal to 4/3. So that the gradient of the line perpendicular to PQ is, just flip this fraction and change the sign. All right, so now we have the two things we need to find the equation of the line. So we're going to write the form for the equation of a straight line, which is y is equal to mx plus c. All right, so what we're going to use is this will be our x and this will be our y. That's the point that the line is passing through. So our y is 2. Our m, our gradient, will be the negative 3/4. And our x, which is being multiplied by m, mx, m multiplied by x, right? This x is this x here, which is 5. All right, so 5 plus c. So what we're really working out here is that the 2 is equal to the negative 3/4 multiplied by the 5, which is 5 over 1. All right, so we see nothing there would cancel, right? Nothing canceling. So we multiply across, so 3 by 5 is 15, 4 by 1 is 4. So what we're going to have is 2 is equal to negative 15 over 4 plus c. So now what we could do is transfer this negative 15 over 4 across the equal sign and return positive. So we'll have 2 plus 15 over 4 is equal to C. And I can simply do that on my calculator by saying 2 plus 15 over 4. And we get the answer as 5 3/4. So let's change that to improper fraction, which would be 23 over 4. All right, so I have 23 over 4 is equal to C. So my equation of the line will be in the form y is equal to mx plus c. So I'll put back the y, I'll put my gradient as the negative 3/4 x, and I'll put in the c that I just found as positive 23 over 4. Now the reason I'm writing it like this is because I'm seeing that they want it in this form. All right, and seeing that I have the denominator as 4 for the gradient, I wanted to write it as an improper fraction with the denominator as 4. So now I can multiply both sides of equal signs by 4 to get rid of these fractions. So here I have multiplied both sides of the equal sign by 4. So what we'll have is 4 times y is equal to 4 times the negative 3 over 4x plus the 23 over 4. All right, so when I multiply this side by 4, this will be an expansion, right? So I'm multiplying 4 by negative 3/4 x. And what will happen is this 4 come like 4 over 1. So 4 over 1 multiplied by negative 3/4. The 4s will cancel and remain at negative 3. So I'll have 4y is equal to negative 3x. So let's put the arrows like this, right? And now when I multiply the 4 times the 23 over 4, this will be 4 over 1 multiplied by 23 over 4. So again, the 4s will cancel, and I'll remain at positive 23. So now I look to the form that they want it in. They want the ax, then the by, and then is equal to c. C is the constant. So the constant here is 23, positive 23. So what I'll have to do is transfer the negative 3x across the equal sign and return to positive 3x. Now notice that the ax is first and then the by. So I'll write the positive 3x in front of the 4y. And this 4y is positive 4y. So I'll have positive 3x plus 4y is equal to my constant, 23. So the 23 remains on the right-hand side. I just transferred the negative 3x across to the left-hand side and turn to positive 3x. So now we have it in the form that they want it in. All right, so a would be the number in front of x, b would be the number in front of y, and c would be our constant. So a would be 3 because 3 is in front of x, b would be 4 because 4 is in front of y, and c is our constant, 23. And that's it. That's the end of the test.